Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 28th April 2023. The problem statement for today is Geeks Village and Wells. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says Geeks Village is represented by a 2D matrix of characters of size n into m, where H represents a house, W represents a well, dot represents an open ground, and N represents a prohibited area, not allowed to enter this area. Every house in the village needs to take water from the well. As the family members are so busy with their work, so every family wants to take water from the well in the minimum time, which is possible only if they have to cover as less distance as possible. Your task is to determine the minimum distance that a person in the house should travel to take out the water and carry it back to house. A person is allowed to move only in 4 directions: left, right, up, and down. That means he or she is the cell I and j, then the possible cells he or she can reach in one move are I and j minus 1, I and j plus 1, I minus 1 and j, and I plus 1 and j. That means in all 4 directions. If we look at the coordinates of x-axis and y-axis, so these all represents the 4 directions. And the person is not allowed to move out of the grid. In note, it is given that for all the cells containing n, w, and dot, your answer should be 0. And for the houses, there is no possibility to take the water, then our answer should be 1. Okay, so this is the problem statement. So here the problem is to find the minimum distance a person in the house needs to travel to take water from the nearest well and carry it back to their houses. So the village is represented as a 2D matrix of size n into m, which is represented by 4 different areas like h, w, dot, and n. Okay, and a person is only allowed to move only in 4 directions, that is left, right, up, and down. So the goal is to find the shortest distance between each house and the nearest wall. One thing to take care is that if the house is located in the prohibited area or there is no path from the house to the nearest well, then we should return -1 for that house. Okay, so again the problem statement is asking us to find the minimum distance between each house and the nearest well. So we need to take care and we need to take into account the open grounds and prohibited areas as well while calculating the distance and calculating the different conditions. Okay, so for solving this problem, the approach which we will use is breadth first search algorithm, which starts at all the wells, performs a breadth first search, and finds the shortest distance to each house. In the BFS, we move in all 4 directions and from each well until we reach a house or a prohibited area. We also keep track of the distances we have covered so far. Finally, we return the minimum distance to each house. Okay, so this is the approach which we will follow. But before going to the actual coding of it, let's go through the given examples and understand it in a better way. So the first example says n is equal to 3 and m is equal to 5. M is equal to 3. Both are 3. So okay, so this is the size of the matrix which is given here. So both n and m both are 3. So and the given grid or the matrix of the village is this one, where h represents the house. So in the first row all are the houses. In the second row, first and the last one is the house. In between, well is there. And for the last one, so again house is there. All the houses are there. So the output is 424, 202, and 424. In explanation, it is given that there is only one well. Hence, all the houses present in the corner of the matrices have to travel a minimum distance of 4. And 2 is for the houses to the well, and other 2 is from well to house. Rest of the all and the rest of the houses have to travel a minimum distance of 2, that is house to well and well to house. So if we look at all the adjacent houses of the well, so they need to travel just 2 distance. What that means, one distance from house to well and another distance from well to house. But all the corner houses, they need to travel 4 distances, and as it is given in the problem that any person can move only in 4 directions, up, left, right and down. So for this person, first he has to travel to this house, then from here he needs to take a turn. That means if he is moving in this direction, it will be a left turn for him. So he needs to take a left turn, and then he has to reach the well. So, and while returning also, first he has to go to this house, then to his own house. So that's why two unit of distance while coming to the wall, and 2 unit of distance while going back. That's why 4 is there. Okay, and for all the adjacent houses, it is just 2, house to well and well to house. Let's go through the second example. So second example says that size of the matrix is 5 into 5, and this is the given matrix here. So here this is the output. So here we can see so this example is given with respect to one particular condition. Here we can see the first house here. Here if you look at all the houses, or that means all the grids, all the values in the grid just adjacent to all to this house, it is n. To the right also it is n, to the down also it is n. So this means this house is in prohibited area. So we cannot reach to any well from this house, or from well to this house, either way. That's why this is said as -1. That means no way to fetch water from well for this house. So the same is given in explanation. There is no way for any person from the house in cell 00 can take water from any well. And for the rest of the houses, there is same type of strategy which we have followed in example 1. So for all other things it is same, but only for this scenario, for this house, there is no way to reach the wall. That's why it is -1. I have just taken another example where dots are also there. So if you look at this example, that there are 4 rows and 5 columns, so dots are also there. So for as it was given in the problem statement, if it is dot, then we have to represent 0. So whether it was dot, then we have represented 0. And if you can see in entire grid, then only 2 houses are there, these 2 houses. So for these houses, the distances is 4, because for this house, any person from this house has to reach this wall, and any person from this house has to reach either this wall or this wall. When we are going through the prohibited, this dot represents here open ground. So if we go to this wall, if we go to this well, then we can consider that area or the distance covered through the open ground. So this person has the choice either to go this or to this. But if it is n, then any person cannot enter that zone or enter that area. So we have to discard that. So the possible way is from bottom, then to the left, and here to the up, then to the right. Okay, so in both the cases we have got 4 output. So I hope both all the examples are clear. So as I have just mentioned before explaining example, that we will be following the approach of breadth first search. We will start from the well, then perform a BFS and find the shortest distance from well to each house. And while searching for all the houses from the well, we move in all 4 directions and until we reach a house, and we keep the track of the distance covered so far, and we return the minimum distance. Okay, so with this approach, I have prepared one solution. Let me just copy it here. I'll explain it line by line what it is done in the solution. Even I have given comments against each line so that it becomes easy in understanding. So when we look at this, then what we are doing here, first we are creating an distance array, 2D array, and we are setting all the values as -1 in this one. Initialize the distance arrays with all values as -1. So we are iterating over all the values, and we are filling it with -1. Then after that, these 2 arrays, this define the direction of the movement. That means either 1 0 0 1 -1 or 0 and 0 and -1. If you move to the if you are at 0 0 at the origin of an what to say, the matrix there, if you are at the 0 0 of x-axis and y-axis coordinates, if you move towards the right, then their x-axis remains the same, y-axis remains the same, but x-axis value increases by 1. So this indicates the rightward movement. This indicates upward movement. Here the value of x-axis remains the same, but the value of y-axis increases by 1. So this indicates upward movement. When we move x-axis towards the left, so and y-axis remaining the same, this indicates the left movement. And here x-axis remains the same, but y-axis decreases. That means we are moving downward. So these two arrays defines the direction of the movement. Then we create a queue for BFS approach. Then what we do, first, instead of finding houses, first we are finding the wells, and while iterating through this complete array, that means 2D array, and if we find a well, then we insert into the queue the coordinates of that well along with the distance. So the distance from that well to that well, that is considered as 0. So we are initializing inserting into the queue the coordinates of that well along with the distance 0. And distance in distance arrow also we have set that distance as 0. If it is prohibited area, that is n, then for that also we are setting the distance as 0. Okay, so this we are doing in this array. Once this is done, then we start with our BFS algorithm, that means BFS steps. So what does this queue contains? Queue contains all the coordinates of the wells. Okay, so as I explained in the approach as well. So first we will be finding the coordinates of the well, and from the well we try reaching all the houses. We need to find the shortest distance to each house from the well. So that's why we are storing all the coordinates of the wells in this queue, and we are performing BFS approach here. So this will continue until the queue becomes empty. But until this condition is true, that means when queue is not empty, then we get the value from the queue and we are storing it in current array. So if we just see here, we were passing the coordinates and the distance. So that we are taking as this one. So coordinates means current x, that we will get from current of 0. The current y we will get from current of 1, and current distance that we will get from current of 2, which we had passed as 0 here. Okay, then after that we check in all 4 directions, that means the movement of any person, and there we calculate next x and next y. So next x will be the value whatever we have got it from this one, current x, plus this one dx of I, this one whatever we have given here. Okay, so it will take in all 4 directions with dx and dy directions. So we get the value of next x and next y. So we check whether the value of next x and next y are within the grid limits. That means next x should not be greater than or equal to 0. Next x should be less than n. Same goes for y as well, next y. And we check the distance of next x and next y is equal to -1. That means we have not visited that cell before. What all cell we have visited? We have visited whether the wells and the prohibited area, but we have not visited any grid that is representing open ground or a well or a house. So we are checking whether the distance of next x and next y is -1. That means it has not been visited earlier. If this is true, then we check if in the grid next x and next y, what is that next x and next y in that grid? Is it that open area or an open ground or a house? If it is an open area or the open ground, then we add the coordinate and distance to the next node of the queue. Because if it is an open ground and a well is located or a house is located beyond that, so we can use this distance to reach either to well or to the house. Okay, and whatever was the whatever was the condition of the prohibited area, that we have already marked as 0. That means we cannot enter that, and we cannot consider even that. So yeah, but if it is open ground, so we add that coordinate and distance to the next node of the queue, and we set the distance of next x and next y as 0. Why this is 0? Because it in note it was given that for a cell containing n, w and dot, our answer should be 0. So we are populating the distance array with 0. But we are adding this coordinate in q so that it can be used. The distance from this one can be used for calculating the distance through the open ground. Okay. So this was the condition when it is open ground. Else, if it is a house, then again, if it is a house, then again we add the coordinates of this plus the current distance plus 2. That means if we are through a house, if we are going through a house to a well, or from well to a house through another house, so for reaching one house, it requires 2 distance, because we have to go through that house and come back. So that's why we are adding plus 2 here to the current distance. And for that particular house, we are marking the distance of next x and next y as current distance plus 2. Whatever we are adding it back to the queue, that will be used for the computation for the further houses. Okay, and for that particular node, we are marking the distance as current distance plus 2. So once this complete iteration is done, once this BFS approach is done, then we just check. So the distance, we just check if it is this one. If it is dot here, if it is here, then we mark it as 0. That means if it is open ground, the distances we are marking it as 0. I think okay, I'll try this later. Okay, so we are marking that the distance as 0, because again the same reason it was given in the problem statement that it can be 0. That means if it is open ground, then we have to mark the distance as 0. Okay, and once even this is done, then we finally return the distances. Whatever is the distances to the array we have computed, that we will return. So the output will be in this format with all the integers showing the distances from each houses to the well. Okay, let's try compiling this code. Okay, so here you can see we have got correct output for this given example. Let's try submitting the solution. So you can see here we have got all the test cases covered. So this problem has been solved successfully in Java. I have even prepared C++ solution for it. Let me move to C++ editor. Let me copy that code here. So here also the logic is completely same. Everything is same. Only the syntactical difference between C++ and Java, that is followed here. Apart from that, everything, checking the range, checking unvisited. Then if it is open ground, then we add it back to the queue with the coordinates. And at last we are checking if the ground is still open, then we mark it answer as 0. So all these things are still there. So these things we have not changed anything. Logic is completely same as it was in Java solution. Let's try compiling this code. Okay, even with this we have got the correct output. Let's try submitting this C++ solution. Yeah, so even with C++ we have got all the test cases covered. So one thing I was just thinking, that can I just try removing this? Does it break anything? Yeah, something is not correct. Okay, so yeah, so we are following so with both these languages, C++ and Java, this problem has been solved successfully. So talking about the time complexity of this solution, so it is in the order of big of n into m, where n is the number of rows and m is the number of columns in the input grid. The algorithm first initializes a 2D array of distances with all values set as -1. This operation takes big of n into m time. because we have those two array here. Let me move to the Java code here. This one, because we have this two loops here, so it takes big of n into m time. It then finds all the wells and set the distances to 0. This operation also takes big of n into m time. Big of this one, we are finding all the wells and we are setting the distances to -1. Yeah, it is then finding the wells and set the distances to 0. This operation also takes big of n into m time, as it involves iterating over all the cells in the grid. The algorithm then performs a BFS from each well to find shortest distance to each house. The BFS algorithm takes big of n into m time, as each cell in the grid is visited at most once. Finally, the distance to water bodies are set to 0, as to unreachable houses as -1. This also takes big of n into m time. So the total time complexity of this algorithm is big of nm plus big of nm plus big of nm plus big of nm, because 4 times this loops are getting repeated. So yeah, but we can say that it is in overall, it is in the order of big of n into m. Okay, so talking if it talk about a space complexity, then here we are using a 2D array of distances which takes big of n into m space, and for a queue for BFS which can have up to nm elements, that means n cross m elements. So a space complexity is also big of n into m. Okay, so I hope both the solutions are clear to you. If you have any doubt, then you can ping in the comment section. You can comment on the comment section. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.